Good evening, everyone. So thank you for joining us on the second meetup of this year. Just to have an indication who is new, actually, who never been here before. Wow. This event, like, who has been there for the last time, actually? Okay, super nice. So this time we are at Nokia, and actually I want to ask for a big applause for Nokia because they're kind of hosting this this event. Super nice. And maybe Klaas, where are you? Maybe you want to say a few words.
Okay, so welcome everyone. Glad you could join us here at Nokia Belgium in our Antwerp office. Yeah, I will be giving a talk last today, so I'll tell you more about myself and what we do then. But some practical things, in the break you can get some refreshments over there where you got the food. And restrooms are around the corner, so just keep going around corners, sort of behind this wall. There's the restroom if you need to take a break. Yeah, apart from that, yeah, welcome and glad to see so many of you here.
So thank you, Klaas.
All right, just a couple of words on the speakers. Tonight we focus on security, so we have 3 topics around security. First, there is Pieter from Redhat over here. He will talk about DevSecOps, so how to put security in your DevOps workflow and your applications. Next, we have Philippe, and he will talk about the security, but then from a network perspective. So we go from 0 to hero. And last but not least is Klaas, who you saw already. And he will go over the Nokia CI platform, so it will be more a show and tell, I guess, from what's running here, if I'm correct. Yeah. There you go. So, Pieter, the floor is yours.
Yeah, hello everyone. So thanks for listening to my talk. So for those who were there last time, we had a little bit of a word cloud, and we, or the organizer asked what was the interest of people, and I think security was one of the big topics or one of the big words in the word cloud. And so I decided to submit this little talk and talk to you a little bit about the advanced cluster security for Kubernetes. And with the StackRox project. So I'll talk about that in a second. So my name, Pieter Lewyllie. I'm a solution architect at Redhat. And yeah, with that, let's go. I'll try to adapt a little bit to the room because it's very spread out. So I'll try to make use of the room and talk to all of you. So just a quick word about the StackRox acquisition that Redhat did. So that's where the link is, also StackRox Redhat. I'm here to talk really about StackRox, and so StackRox is it's a project which really focuses on, as we mentioned, DevSecOps and really bringing security in your Kubernetes environment and doing that in a Kubernetes native way. And I'll talk a little bit about that. So it used to be like a proprietary company. Since the acquisition last year, Redhat has open sourced the project, so you can find it on the GitHub address here. So you can find all the code. You can also install it on your Kubernetes distribution of choice. So yeah. It works on I've got some people who run K3s or kubeadm, that's also possible, or on your XKS. So I think we'll all agree that Kubernetes is the standard to deploy our applications. We are all doing today, right? We're all at the Kubernetes meetup, so we're all doing microservices architecture. We're all doing declarative definition, immutable infrastructure. Well, hopefully, at least, and we're not doing lift and shift. Yeah, what we're talking today is really how are we going to secure the supply chain, how are we going to secure our infrastructure, and how are we going to secure the workloads to really achieve, these DevSecOps methodology and put security in the middle of our pipelines. So To cut to the chase, I'm going to talk a little bit about the use cases of StackRox and be as direct as I can be to explain to you what StackRox does in a very practical and non-marketing way. So what everybody does, I would say in the market, everybody and his dog, is vulnerability management. That's also part of the StackRox project. So we're going to look at, if you have vulnerabilities in your images, in your deployments. So not only in your images, but look at also in which deployments they are. We're going to talk about network segmentation. So if you're not aware, in Kubernetes, all pods can talk by default with all pods. So it's open connectivity. So you can trust your developers to write their own network policies and do it the right way and have everything secured by default. Or you can use a tool like StackRox and see what's actually going on and what's talking with what. Configuration management, so we're going to look at things like, do you have a lot of service accounts which have admin privileges? Do you drop privileges on your pods? Do you use environment variables with maybe secrets in there? Stuff like that. So we're going to highlight, let's say, some bad practices in the environment. We're also looking at compliancy, so all the CIS, NIST, those kind of frameworks, your own frameworks if you wish. Risk profiling, I think, is an important concept. So many security tools out there or security projects out there are going to look at, are going to give you a lot of hits on issues that are in your cluster, and you get a whole big list of problems in your environment. And to kind of see the tree in the forest, we're going to look at risk profiling and looking at your deployments and giving them a risk score, and so that you're able to see maybe if a deployment in your Kubernetes environment is more at risk as others. So just to give an example, if you have a deployment which has a medium severity but has exposure to the internet and has certain ports open, has certain maybe cluster admin privileges, stuff like that, would get a higher score than maybe a deployment which has a very high security issue but is deployed in your lab environment and not exposed to the outside world. And then finally, detection and response, a whole bunch of things we can look into there. Not going to have enough time today, but maybe we're going to look at what we can do in terms of enforcement and what we can also do in terms of maybe looking if we have a log4j in our environment, stuff like that. So I promise I don't have a lot of slides. I'm not going to take you through the whole half hour through slides. I'm almost done with the slides. So StackRox is really looking at the full lifecycle of your application. So we're looking at the build, deploy, and runtime of the application. So at the build time, and you can see here at the core of StackRox is a policy engine. So we're really looking at enforcing policies at those 3 stages. And so an example could be at build time, we're going to look at, do you have, well, maybe vulnerabilities above a certain score threshold, or maybe you're using package managers in your images and deploying those to production. Maybe not the smartest thing to do, right, if that can get used by someone which is in your pod. So those type of things. We also integrate with CI, with your CI. So your GitLab, GitHub, Tekton, those type of things. And so what that means is that we're trying to get feedback as early as possible, right? So part of this whole shift left movement in security, we're trying to shift security as left as possible in your CI pipeline. And so by doing that, we can fail, for example, your build through that integration. Then we have deploy time, which is well, integrating with your Kubernetes admission controller and preventing, for example, the deployments, bad deployments from happening, or signaling bad practices like using the latest tag or using environment variables with secrets or clear text passwords, as I mentioned. Then there's also the runtime. So you're looking at, well, what kind of processes are running? Do I have maybe someone using Netcat in my environment, someone doing crypto mining, all those kind of things. We're never going to interact directly with processes, like I would say many legacy security solutions out there would do. It's going to really be at the kube native integration. So, for example, in case of a process misbehaving, the whole pod gets killed. So it's easy for Kubernetes admin to understand, but that means that your application needs to be designed in a Kubernetes native way, right? Because if we kill the pod, it needs to react on that. And I thought I muted my phone, but it seems like not. Apologies. Okay, so last slide is the architecture. So we have the central part, which is what I'm going to show you in a second. It's where you log in. It's where you, well, it's where you can also see all your Kubernetes clusters that are being monitored. So here we're monitoring 3 clusters. They're all reporting through to the central part. And you can deploy it, as you see, on any Kubernetes using Helm charts, operators as well, if you're familiar with that, or just CLI. In terms of components, so on every cluster that we monitor, we have a sensor, an admission controller, and a collector daemon set. So basically, the sensor is there to monitor your cluster, interact with Kube API, and really enforce also your policies, talking with the admission controller, for example, which will allow or disallow certain things according to your policies. And then you have the collector, which is really the deep, low-level stuff, where we're collecting network activity, process activity, those type of things. So it's usually done with, hello, all good. It's usually done with kernel modules, although now we're moving to eBPF for those that are interested in that. So eBPF extensions is the default today. But the result is the same and transparent for the user. Okay, I said I don't do any more slides. So let's go. And I think we started a bit late because I don't have a timer. So on the organizer side, let me know. Right, so what I'm showing here, and I'm using some Redhat themed products here, right? OpenShift, our Kubernetes distribution. But everything I'm showing here is the same on any Kubernetes. So you can also the Tekton part here. So Tekton is a CI/CD tool, which is in OpenShift, but you can also install it on any Kubernetes. The great thing about it is it's using CRDs, it's extending Kubernetes, it's declarative, using YAML and so on. So there's no engine or anything like that, and every step of your pipeline is running in its own pods, in sequence or in parallel. For example, these 3 are in parallel. So the interesting thing here is I've integrated, yeah. Oh yeah, sure. Hopefully it doesn't get too bad zooming in, but I'm zooming into the part which is interesting to us. Thanks. is the image check. So you can see it failed my build. So that's the whole idea, is to give developers feedback. So if I'm a developer, I get that, and I see here, now it's a bit zoomed in, so but I can see my log snippet there. It's saying, okay, I have 3 policies violated, and I have 1 policy which is failing the check, which is failing my build. So that's where you can decide if you want to enforce or not. You can inform or enforce. Here we're enforcing, and we're enforcing for severities which are at least important, so at least have a score of 7. We don't want to allow that. So if I'm a developer, I want to dig deeper. I'm going to click on this, and I'm going to look at my log snippet, and I need to zoom out maybe a bit. But I think you can see what it's giving me here as a developer is, okay, what are all the things that I'm kind of doing wrong or that I should be aware of. So you can see here it breaks the build or not, and it's giving me all kinds of feedback around policies which are failing. And so I can see, for example, okay, I have Spring for Shell here. I have all these CVEs, and yeah, I have also suggestion on how to remediate that. Right. So that's one. I can also then see, for example, here, this doesn't fail my build, but I can also see an image scan with all my vulnerabilities. And I put here a link where I can go to my StackRox UI. And this is actually the first time I'm going to open it today. This is very specific to this image, but then I can review all the details of that image. So I can see here, yeah, all the CVEs. I can analyze my image. I'm not going to do this in detail now, but this kind of feedback is very interesting, I think, for developers to get straight in their CI. And then I have also my deploy time policies, which I can see here. For example, I'm using latest tag, right? And then it says, okay, consider moving to semantic versioning. Or use, you know, CPU. I didn't specify any CPU requester limits. Could be abused as well. So I'm specifying this as well. Okay, so that's for the CI integration. I'm now going to show you a little bit more about StackRox itself, or I'm using actually the Red Hat version, which is Advanced Cluster Security. You're going to see if you install the upstream, it's going to look very similar to that. This is just what I have in my lab. So here, when you log in, you basically have a dashboard showing you all the violations, or your images which are of most risk, deployments, you have aging images, and then all kind of things which you would expect, I would say, from a dashboard. And I think I'm in the wrong one. Yeah. So I had some issues with Wi-Fi when coming, so I just need to, yeah. Okay, so I can see this. I'm just going to highlight two things. We talked about risk, right? And I think risk is one of the things which will really help you see, okay, do I have actually something bad in my cluster? Here, if I click on risk, I can see all the deployments of my cluster. I can see I have one called Visa Processor here. If I click on this one, I can see on the right my risk indications, right? So I can see, for example, that this deployment has all these policies, and I'm definitely going to need to zoom in here. Hopefully this is visible for everybody. So I have, okay, well, I've got some Apache struts. Emergency deployment annotation, that's actually because this is such a bad deployment that it's the only way for me to deploy it on my cluster is to actually add an annotation to say, okay, this is an emergency deployment. I want to really deploy this. I'm in production. I need this, but so it will, of course, increase the risk score as well. Then, yeah, I have environment variables which contain secrets. I've got privileged containers. I've got SSH port exposed, and then I can see in runtime I also have a shell spawned by Java. We'll see a bit more about that. I've got sysadmin capabilities. I have netcat execution detected. Well, no resource limits. It's a privileged container. It's an old image, so it's more than 90 days. Time is very unkind, right, to our container images. If you leave it there, you're going to have a lot of CVEs after a while. And then I also have my Ubuntu package manager in this image. So meaning that if, you know, well, I actually see it in the next one here in the suspicious process execution. So we see that someone logged in, has typed in apt-get and installed netcat. It's getting a bit obvious now. And then he's doing shellattacker.com with some command. Then we also see all the image vulnerabilities. I've got two containers, sidecar and the normal one, which are both, you know, a lot of CVEs in there. And then I can see also my service configuration. I can see that I have sysadmin capabilities. No capabilities were dropped as well, which is a good practice in your Kubernetes environment. Yeah, and then I have my port exposed. I have useful components, apt, netcat, wget, those kind of things. A lot of components, and then these images are very old, so like I said, it's a demo kind of thing, so using old images to show what it can show. And then last but not least is the RBAC. So I can also see that I've been granted cluster admin privileges, meaning that, well, if this pod is taken over, you can take over the whole cluster, right? If I go to my process discovery, I can see here, so it's doing some kind of a baselining at the beginning of the life of my pod. And when things go out of that baseline, someone logs in, does netcat, you can see those things popping up here in red. Yeah, so netcat. I can also decide to tweak that and add and remove stuff from my baseline. Okay, and then I can also decide to view this in a network graph. And now zooming in is breaking the UI. So I'm going to try and make this as clear as possible. Removing the legend, don't need that now. So what I can see here is basically I've selected the namespace. Well, it's been selected for me because this is the Visa processor deployment. It's in the payments namespace. And what I can see here is that I've got a jump host here, which is out of baseline again from communication from this pod. Same mechanism as for processors, for processes. And it's connecting to my Visa processor pod here. So I can see this, but I can also see what's allowed, so what are network policies in place. Here I don't have any network policy in place, so it's all red dots, meaning it can be reached from the outside world, it can reach each other in my Kubernetes cluster. Because there is no network policies. What I can do with this as well is say, okay, this is the past hour. I can go, different times, and I can say, okay, generate me the network policies of this. If I do that, I get the YAML of all the communication that has happened, and I can use this as a baseline. Maybe you can give this to your developers, start as a baseline. I'm going to try and zoom out because when you're zoomed out, then you can see here on the left all the network policies being simulated also on the display, and you can kind of analyze it that way. Soon, we're working on something to not only do this live like we're doing now, but also based on your YAML files. So if you have some YAML files, you could derive also network policies from there based on what ports are exposed and whatnot. So that's also going to be an option. And I think I'm running slowly out of time, but those are the two things I wanted to show. Yeah, in the UI, there is much more about StackRox, so I invite you to go on the GitHub and try it out. If you're actually interested more in the demo that I showed before, so about with the CI integration, actually we have a GitHub page where we explain all the different components. I just shown you a small piece of it, but here you have a full pipeline. I'm going to zoom in a little bit. You can see all the components. We're using SonarQube, Nexus, also doing some pen testing and so on. Actually, we're just extending it using Sigstore. It's a thing we're also really investing in at Redhat. So to be able to sign your images cryptographically so that no one can, let's say, inject something in your supply chain and inject bad stuff that way. So if you're interested in Sigstore, there's also on the GitHub already the extension. And maybe one of these next talks, I can talk more about Sigstore. But if you're interested, it's already there. All right. I think that's clear by now, but just in terms of branding, so StackRox is now Advanced Cluster Security, so that's the product. The upstream is still StackRox, so StackRox.io is the upstream project which you can use and contribute to. We actually have also a StackRox channel on Slack, on the CNCF Slack, so yeah, you can interact with us there as well. Final comment is KubeLinter. I think it's also an interesting project in the same kind of vibe of what we're doing for network policies, deriving YAML. This actually reads your YAML and will give you an wow, it's way too small on these screens, but normally you would be able to read on these screens some feedback which is giving on your YAML files, right? So if you basically let it run against your YAML files, it will tell you, oh, did you think about CPU limits, you didn't specify it, all those kind of things. So yeah, with that, thank you. I don't know if there's any questions. Nope. Yeah. The stats collections informations about that's a good question. So the question is, if we look at CPU increase or you know, those kind of stats, I'm thinking right now, I don't think StackRox does that by default. You will have those baseline deviations. So if you have a new process or something like that, but it's more in terms of yeah, changes in memory or changes in process, but not really changes in CPU usage per se, as far as I know. Yeah. Okay. Any other? Yeah. Yeah, so that's thanks to the collector. So it looks at really the network traffic. It does some aggregation, and yeah. So that's today the eBPF extensions who do that. Yeah. So the question was how do we know, or how does the project know which pods communicate with which? So thanks to the collectors. All right. Cool. Thank you.
All right. So thanks for the opportunity to be here. Thanks, Nokia. Thanks to the organizers. I appreciate all the effort you put into. I know what effort it takes. So I'm going to talk about Kubernetes network policies. If you want to follow me on Twitter, I did especially the effort to have a moving Twitter icon. So I'm Philip. Actually, I'm a cloud consultant at Fortinet. Basically occupied with AWS, Kubernetes, and everything which is around DevSecOps and CNAP and that kind of stuff. I'm also one of the co-founders of Bricon. I'm particularly proud on it. It's one of the biggest hacking conferences in the meantime in Europe, except Black Hat, but way more cheaper. So if you want to check it out, it typically happens at the end of September, beginning of October, but I think next year is last week of September. It's a fun hacking security conference in Mechelen. Beside that, I spent all my free time writing stuff on GitHub. I reached 100 repos. Do some blogging on Medium. Feel free to check it out. Started a project together with somebody in India to actually write live labs, which you can try out. It's free. It's not that fast, but there are a few on them. And beside that, I love training and pen testing, so breaking stuff. So let's talk about Kubernetes and network policies. So there was one thing which is very important to understand when we talk about network policies. Although we might say network policies in Kubernetes, it's not something which is part of Kubernetes. Yeah? Network policies can be defined through the native Kubernetes API, but whether it's implemented or not, it's another question. Implementing network policies is basically done through the CNI, so the container network interface. Now, you probably all know about Kubernetes. Kubernetes is a very big thing, and then they figured out how to make plugins. So there are plugins for the networking. So Kubernetes does not actually explain how the networking should work. There's some simple rules to adhere to, and that's what actually the CNI vendor or project implements. That can be Calico, Cilium, Azure CNI, AWS, VPC CNI. They all do it in different ways, as long as they respect the simple rules. Don't go and look too far about all the complexity. It's basically a binary on every node that makes sure the networking connectivity is configured. So, as I said, there are a lot of them. So there's a lot of things to choose. Every vendor will tell you something else. I've worked for vendors, I know. But when you choose a CNI, one of the problems is you probably have to choose it when you create your clusters. It's very hard to migrate from one CNI to another. From OpenShift to OpenShift, yes, but not from Calico to Cilium or not from Calico to Azure CNI. Forget it, that's incredibly difficult to do. So the things to think about is probably what do I actually need? How many pods do I have? Do I need to segregate in my data centers? Perhaps you might have like hundreds of nodes in different racks in different data centers. So quite a lot of networking architecture you have to think of to choose the right CNI. If it's quick and dirty, you can use Fennel. I don't even think it's supported anymore, but it was the default one. But setting up a CNI is not that difficult anymore today. So the CNI itself is basically very important because the CNI is actually the piece in Kubernetes that will make sure that you can connect your pod to the network. And connecting that pod to the network is basically just making sure that that pod gets an IP address, somehow hooked up to the virtual router or switch inside of the node, so that it can communicate. Yeah, that's a lot of, what should I say, low-level Linux commands to make sure that it gets hooked up on the networking. That's what the CNI does for you. The CNI quite often doesn't even interact with etcd. It can be a simple binary, and believe it or not, a simple text file to manage the IP addresses. More advanced CNIs, they store all their stuff in etcd. You can use it through a CRD or something. So. Now, the point is, how these CNIs do all that stuff is less important for today. The most important thing to think about is that if you want to use network policies, choose a CNI that supports network policies. Yeah. So I use Cilium today because I love the ePPF part of it. Sorry. But you can choose Calico. If you go to AKS, you can enable Calico network policies on AKS, or you can use an own CNI. Even today, it was announced that Cilium will have full Cilium support in AKS natively. It's in preview. But you will see that there are tons and tons of difference, but just make sure that they implement network policies and comply with at least the network policies as defined in Kubernetes. Yeah? There are projects that do not do that totally in depth. Now, if you think about pods, they get an IP address. The IP addresses, it really doesn't really matter where they come from. They're chosen from what is called a pod cider, which is a long range of IP addresses from which the CNI picks one. That could be a total virtual network, like an overlay network that never sees really something on the network, or it can come directly from the network. It really doesn't matter for Kubernetes as long as your pods can communicate. All right. Pod cider, also be very careful. You might think a /24 is enough. Forget it in Kubernetes. Will end you up with 2-3 nodes and you're out of service. So typically it is 10/8 or something. Yeah, and then yeah, make sure you plan it in your cloud and in your infrastructure and so on to make sure it works. Don't confuse it with the service cider. The service cider is actually also a range of IP addresses that is used by kubeproxy to implement actually the services, so the basic load balancing to make sure that pods can communicate through an abstraction. All right, we're not going to cover that today, But that's another side you have to think about, not to use it anywhere else in your network. So the cool thing when you start with Kubernetes is that the Kubernetes network model is actually defined as a flat network. That means that if you're sitting on node 1 or node 2 or node 3 or node 4, we don't care. We get an IP address out of the same range, and the CNI specification says that every pod on any node can talk with any pod on any node, which is super cool if you think about it, if you play around. But if you work with data centers, if you work with clouds, if you work with firewalls, the first thing they always say is segment, segment, segment. And for sure in Kubernetes, because you might be hosting different environments, different projects, different apps in different namespaces. And the namespace concept in Kubernetes is pretty cool, but it doesn't count for networking. Maybe a developer can only go in QA and not in prod, but prod can talk to QA without any worries. Yeah? So it's also a very easy way for an attacker, once he gains access to Kubernetes, to move around and actually connect to anything he wants to, including the control plane. It can talk to kube KPI, for example. All right. Now, in essence, I added these slides to give you an idea about what happens, but basically your pod, if you look at a pod, there are basically two containers in it, one which is probably having your application, and one is called a pulse container. Yeah, it really doesn't do anything except having an IP address. It's the one all the other containers link to. Has typically an Ethernet, like you would have on any machine. If you do ifconfig, you will see ETH0, one interface, which is hooked up to basically the Linux kernel. How they do it, whether it's a virtual switch or with virtual routing, we don't care. And the CNI will make sure that the CNI component will update the routing so that the CNI will know, or the routing will know, where to send it to. It could be straight over the network, like I think KubeNet does, but it could be through an overlay. It could be to a VXLAN. It could be through an IPsec tunnel, whatever. As long as the routing-wise they can talk to each other without any type of address translation. So two pods that talk to each other, they should see each other's IP address. All right. For example, Calico, they will use BGP so that they know which blocks of IP addresses are assigned to each node so that they can talk to each other. But if you have a VXLAN tunnel, for example, you won't have BGP. So that's why you have to choose in the beginning what will suit my use case here. Important thing to note is that pods that talk to each other should not be address translated. But what happens if a pod wants to connect to the internet? That's a big problem to solve. Basically, when a pod goes to the internet, and once the CNI defines that, okay, this is not in cluster, it will actually send it, let's say, to the next hop, firewall, router, whatever. And it will actually do address translation by default on the node it gets out on. So if you have 3 nodes, it might be that what you see here are 3 different IP addresses, which are the IP addresses of the nodes. There are some enterprise products that try to solve that problem, which is a very big problem because it's very hard to identify at the network or underlying network which application is actually reaching out to the internet. If you would block that IP address, you block out a node. So you see it coming, it all works fine, but at a given point, if we want to secure these things, kind of gets complicated. So, as I said, by default, there is no isolation, no segmentation. Airbag won't solve anything. So, by default, anyone can talk to anyone. Pretty cool if you're a hacker. But if you want to control it, you basically have to go to the concept of network policies. Of course, this would have made sense if I said that, if Pieter wouldn't have said they can solve it with eBPF. There are quite a lot of other tools that try to implement enforcement, but typically not through network policies. Network policies is something that is implemented in the kernel. You can do it on different levels. I'm not going to argue how StackRox does it, Aqua does it, Palo Alto does it. They do it all on a different way. But network policies is basically, let's say, the way it was supposed to be in Kubernetes, and still is. Network policies, they can actually control, and this is important to understand, flow to or from a pod. Now, if you're a VMware guy or a Kubernetes guy, this makes sense. If you're a networking guy that works with firewalls, this doesn't make sense because we typically think of a central gateway. Doesn't make sense here. It's one flat network. And network policies is the way to go. An important thing about network policies is pods are ephemeral. That means that a pod can come up, and my Nginx server can have 10.10.10.1 as an IP address, and StackRux says, oh, this guy should be killed, spin up another one. It spins up on another node with another IP address. And so identifying these pods by an IP address is very hard, impossible. Yeah. So identifying applications comes back to a fundamental concept of Kubernetes is by labels. So you're going to actually say pods with these labels can communicate with pods with these labels, yeah, or can communicate to the internet. Yeah, so label-based is a very important thing to keep in mind. On every Kubernetes cluster, you can apply the manifests I provided in the lab part or demo part. Whether they're implemented or not, you have to check the CNI. For example, Docker for Mac will not implement it. Yeah? So now comes the tricky part. Even if you plan to use network policies, there's no tick box that you say turn on network policies. They're on by default if you have network policies. But by default, no network policies are applied. So if you have Calico or Cilium running, and you do not do anything with network policies, fine. And all traffic is allowed. The tricky thing is, once you apply a network policy to a pod, so to a label, then only the network policy is valid. So if you have an Nginx pod and you say app equals Nginx, I allow port 80 to connect to, all the rest is by default blocked. So you can do very nasty things with network policies, like locking out an entire cluster if you want. Yeah? So think about that. As long nothing is applied, you can do whatever you want, going into a pod or getting out of a pod. Once you start applying policies to pods, and that could be in selected pods within a namespace, yeah, that's the pod network policy that counts. So, all right. So by default, you do nothing, and anything in your namespace can talk to anything in the namespace or even in the cluster. I don't know if I mentioned it somewhere in the slides, but network policies, the native network policies, they are applied on a per namespace basis. That means if you apply network policy on namespace prod, only the pods in namespace prod are affected. QA can still do party. All right, so by default, anything happens. Now, I don't know if it's a good practice. It's a good practice, but be careful by simply copying this. So by default, and from a security point of view, you would say, I'm not going to allow anything except what I want to be allowed. That's a great idea. That's how firewalls work. That's how your egress firewalls work, and so on and so forth. Now, the trouble is, with network policies, there is nothing like drop all traffic. It only supports the native policies, only support open up stuff. So the first slide is basically a very big exception, and it's very hard to understand. But as you can see, it's a networking policy. It's applied in a namespace called my namespace, so it means you have to do it for every namespace. The pod selector is this crazy two brackets thing, which basically means everything. And types are ingress and egress, which are empty. And this is a very tricky thing. This is actually a policy that says apply on all the pods and allow no rule, which basically means no communication. So this is a very tricky one to understand, but basically it's applied on all the pods in a specific namespace. It has no ingress or egress rules. So it's selected by the selector, so you're dropped. So if you do that, you see a lot of red things popping up in your management systems. All right, but let's build it up. So in the next phase, I'm going to explain what an ingress policy is. That's a policy that will allow traffic to flow into the pod. So again, it's put on the namespace. It only selects pods which have a label like role equals DB. So in this case, this one. And it will allow only ingress, which is into the pod, from pods which have a label like role frontend, so that one, on a specific port. At this moment, when you apply this, keep in mind there is a block all happening. You're going to add a rule on top. You always have to think these are accept rules. Yeah, it's going to make an accept saying that we allow TCP to flow in from this one. This is all coded into IP tables in your nodes or enforced by eBPF. Yeah, but I guess most CNIs still do it with IP tables, except Cilium, Calico. They will start doing it with eBPF, but at the end of the day, the behavior should be the same, hopefully. So at this moment, only this one can talk to this one. This is the ingress. The rules, the enforcement is here. Role frontend can still do whatever it likes, except we said don't do anything. If we add an egress rule, you see, egress, we can do similar things, could be labels of an IP address. And again, it's only applied to a specific pod. So in this case, only a role helper would be allowed to connect to this IP address. I removed this rule because that's rule list. So they are basically, or should I say, cumulative in nature network policies and not overwriting, because every network policy you add basically opens another hole. Yeah, all right. There is a big caveat here. If you would have done what I've said to you, you would have probably already called me or killed me. Because if you would apply these rules, your pods will not be able to do any DNS resolving anymore. They won't be able to connect to core DNS or whatever is responsible. So think about that. If you apply a default deny stance at the beginning, DNS is stopped. Now, you might say from an IP address to an IP address, I don't need DNS. That's true. But your pods, talking to pods, typically talk to the concept of services. And services are basically called up on a name, which is in DNS. So don't forget to do that, or you combine this rule with the default deny all rule to make sure that your pods can still do DNS resolving if necessary. That's the biggest support and the most support calls I've ever seen in my life. Yeah? Now, when you see all this, you say, oh, this is all very simple, but this is YAML, so syntax need to be correct, spaces need to be correct. And one of the big downsides here is, by default, you have no logging. So if something is broken, or you make a mistake, you basically have to go to TCP dump and see, okay, it leaves, and oh, nothing comes in, which is a terrible, difficult thing to do. Yeah. So think about that, because you might have seen in the documentation of Calico or Cilium, we support global policies, but if you would apply a global policy, like I did on a namespace, you cannot even log in into the cluster anymore. Yeah, so be very careful with that. Now, one thing people typically don't do is they do not apply that default deny all rule. And then they complain that it doesn't work and just blocks stuff that it should not stop. If you forget to deploy that default deny rule means that all the pods on which you explicitly didn't do anything still have full access. They can do whatever they want. Except that poor RollDB pod on which you set to enable port 6, whatever, 379, yeah, that one is not allowed to do anything anymore, yeah. And another big caveat is if you only apply ingress and you not put anything on egress, Kubernetes or IP tables or whoever needs to implement it consider it as a not selected pod. So if you do not specify egress policies, by default all your pods can still do whatever they like. So there are a lot of things to keep in mind. I didn't invent this. Yeah. But make sure if you do not specify egress policies that you're aware that everything can leave as much as it wants. And only on the ingress part you can have some blocks. All right, so make a strategy, know what to do. This can be easily automated in a CI/CD system, for example, yeah, and do it part by part, yeah, but not global cluster-wide policies. It's very hard thing to do. Yeah. No, I find it very useful for some use cases. I'll have a small word on it right away. I'm just saying that if you would apply a default deny all policy at the very beginning, it's you have to go through 4 days of hacking to get back. Yeah, Kube API perhaps not, but it might be that kubelet was blocked or another pod, like, for example, in the case of Calico, the Calico node control, or the Calico node daemons, they are pods and they are blocked. And it basically goes down to cleaning up IP tables and hopefully fast enough before it's pushed again. Yeah, it's very painful, believe me. So policies, am I against it? No, because it's the only way to at least have some segregation. Yeah. If you understand the concept that is applied to pods labels, it's basically fairly easy. And the cool thing is, I typically use roll red or roll blue, but think about, you could basically just create a label, say, internet allowed, internet denied. And you can just create a policy that says, if you have the role internet allowed, you can go to the internet. If you have a label called denied, you cannot go. So you can play with that. And it's fairly easy that if you have a pod, by just changing the label, you make it fall into a network policy. Now that can be easy, but that could be painful also. Yeah. So it's only applied to pods, and that's not always true with more advanced CNIs. You can select to or from namespaces, pods or CIDR, so an IP address. Also make sure the namespaces, it's not the namespace name. Yeah? You need to label your namespaces. It's always based on labels. And it also only supports a TCP and UDP. That means like ping will always work, which is probably the most used tool to test connectivity. If you use more advanced things like Calico and Cilium, they have custom CRDs. So you would basically see that it's not a default networking policy, but something with Calico in the name. They have global policies. Cilium also. They support things like deny, logging. Cilium logs by default, Calico not. It basically does it in the enterprise. It can accept, it can pass, it can do tiering, very complex things, but at the end it all boils down to the same concept. Some CNIs start to use layer 7, so you can actually see the gets and the puts and the posts in it. Some can use DNS names. It's particularly interesting, for example, if you want to implement things like thread feeds For example, you might have a thread feed that has a list of botnets. You could say these pods cannot connect to botnets. As I said, it's important to do that in the cluster and not outside of your cluster, because if you would do that outside of your cluster, you probably see nodes being blocked out instead of pods. Yeah? And logging, all right? I don't know how much I'm doing on time. How much do I have left? Infinite, all right. All right, just asking. So what I did was, I forgot what I did. All right, yeah, I put here a link. You will get the slides somewhere or you ask me. I put together a lab so that you can play around this scenario, yeah. Everything is on GitHub. And also there's a similar lab on Cloud Yuga. It costs nothing, just click deploy lab and the sponsor will pay. So what I did was basically just create a copy pasting for my own. Yeah, I will. It's better, yeah. So it just starts from the point that you have a Kubernetes cluster and that you have a CNI implemented with network policies. That could be AKS with Calico, that could be EKS with Calico, could be an on-premise or a self-managed cluster. And the cool thing, I was so happy this morning, Cilium launched a preview of Cilium in Azure CNI. So the Azure CNI at a given point, that's up to Microsoft, be replaced with Cilium. But there is a way to fairly, with 4 or 5 commands, you can configure it. And you can use Cilium and all the advanced, up to a certain level, features. So you should be able to do this entire lab, including the last one. So let me close this down. So just for the fun, I'm gonna create here a few namespaces. Yeah, I can do everything. Yeah, I'm just going to copy paste things in here. And this is, hopefully you'll see some logging. So I'm going to simply deploy here. No, this is just. Oh. Luckily I was. All right. Now everybody is thinking he's putting his stuff in their box. All right, so should be back up. And here, let me try again. Let me log out here. Okay. All right. Let me see if this should be okay. All right. Quickly check if I have connectivity again. Nope. It's not that I didn't prepare it up front. Yeah, now it's working. All right, so what I have here, this is just the same Kubernetes cluster. I'm going to launch a test pod here. I'm going to issue my commands here. And this was actually in an effort to show you the open source part of the logging in Cilium. So let me go back here. I'm going to do this again. Just a simple thing. I'm going to create 3 namespaces. I guess you're aware with it. I'm going to deploy Kubernetes, an Nginx pod, 3 replicas. You can read this afterwards, yeah. And I'm going to basically create a service. And if everything worked out fine, we should actually see that these pods are created. I added a show labels one, because if you want to play with network policies, this show labels part is your best friend, all right? In advanced CNIs, you can apply network policies to services. Yeah? That's also a very tricky one. But again, that means that you can also check, of course, the labels of your services. Now, to play around here, I made this very complex thing here instead of me always typing the pod IP address again. So just going to put a pod IP address, and I'm going to run here a debug pod. So you see it's running in the same net namespace as my Nginx service. And if everything works out fine, I have a pod. I'm going to try. So I created the test like doesn't do an NS lookup to see if core DNS works. Can I connect to my cluster IP address? Works fine, yeah. And can I curl to a pod? Should be fine also. You see, this is actually very useful information. So it tracks with eBPF all the connections that are made in that cluster, yeah. This is very hard to get. Maybe some of you use flow logs or something similar in one or the other cloud. Might give you similar results. The problem is with these solutions that you do not see which pods communicate with which pods. It's more like IP address to IP address. Here you basically have which pods and even which identity talk to each other. So pretty cool, certainly for demos. I'm not going to use it, but you can see the similar things in the UI, yeah. But it's a little bit complicated to do that, switching back all the time. But you can do exactly the same in. So we're going to do the magic thing. We're going to apply the default deny all policy. Oops. Network policies, they don't forgive you any mistakes. So right now, this is implemented basically in real time. It really doesn't take a second to do that. And it also acts on running pods. So if I would do exactly the same thing here, this pod is open, yeah, and nothing will work anymore. And if DNS doesn't work anymore, for sure services won't work. And if I would curl to the pod doesn't connect anymore, yeah. Always check if you are in a situation where you think like, oops, always check this simple command, get network policies. Of course, I was nice to myself and I called it default deny, but it could be basically called anything. And you see pod selector none, so it's a little bit misleading, but it's actually all pods, yeah. So you can check the connectivity as we did, it fails. So the first thing we're gonna solve, all right, is the DNS thing. Now, again here, I'm gonna apply this rule here. And now DNS will work, but take a look. You can do whatever you want here, but of course we don't want to make something like we allow you to connect to TCP and UDP port 53 anywhere. We want basically a rule that only allows you to connect to the core DNS ones. That means that you need to put at least a namespace, because it's in kube system, and a DNS label for the pods. So if you do show labels, you can see these things, but probably, I already did that, and you cannot overwrite these labels, but probably your kube system namespace is not labeled by default. So you can do that, but you will see that if I do this, that basically it's already labeled. Yeah, that's why it says not labeled. Yeah. So we can do the same trick here. You will see that at this moment we have like 2 policies that select every pod. Yeah, you can do describe. You can see the entire stuff, but I don't have all that time here. So if we want to check all this, we can actually say NSLOOKUP again, and you will see that now NSLOOKUP works. But curling the pod or curling the service, yeah. Sorry, curling the service, I did something wrong, but I did NSLOOKUP. But if you curl the service, it doesn't work neither at this moment. At least you can see here in the logging that something is dropped and allowed. You will see that basically your DNS is allowed. So it's a very good and easy way to start learning and debugging this. Because turning this on forever is incredibly expensive because it generates so much logs and overhead. It's not something you're going to turn on in such a way forever, but for debugging, it's super interesting. It's running, Hubble is a client that you install, but it just connects to the Cilium API, yeah. But if you, I can give you the setup thing, it's pretty easy. It's just a nightmare on the port mappings, but that's because it's a private cluster. All right, so the next thing what we want to do is solve the incoming egress. So similar here, allow HTTP. We're going to match all the Nginx service. We're going to say from every pod on port 80. Every pod, keep in mind, it's only applied to the namespace. So this rule is only applicable in the namespace. So doing this and copy paste it should do the trick. If we do, for example, it's not I'm too lazy to type, but I have thick fingers. And not only thick fingers. So you see, now you actually see the labels. It does select, all right? If we check the connectivity. Oops. Anyone, any idea why? Yeah, for my testing pod, I can still not leave. I can enter the other one, but cannot leave. So, and now, right, so yeah, we can do all that check again. So I need to allow the egress side, and as you can see, it's allowed on the pods which have a label as debug. So if you want to implement this in practice, you could create, you say, you cannot connect to these Nginx servers from inside the namespace, except if you have a pod with a label like debug, so that you can identify it. Yeah. So let's do this. And if I'm very lucky, we should actually see that right now everything should work as we expected. Come on, cannot be that difficult. Yeah, okay. So if you do the services one here, sorry, this one, yeah, it should work also. So this no, it's a very good question. Your network policies only open specific connections. So as long as you say allow port 80 and allow this, it's just punching more holes into your default deny policy. So there is no concept of blocking. The only reason it doesn't work is because, as said in the beginning, every pod has no policy. That's why it behaves like this. All right? When you use Calico or Cilium, you can do drops, and then you have a very fair point. But like Calico, they have an ordering mechanism where you can say, put these drop rules before or after. But in pure Kubernetes native behavior, you can only open more holes than you cannot close, for example, port 80. You cannot do that. Or you would basically block everything and open all the rest. All right. Now, if you wanna, I'm sitting in the prod nginx namespace. If you wanna allow it from a dev namespace or something else, I think I use hacking here, the policies become more complicated. Now, as you can see this one, and that's a tiny thing here, but you see there are 2 entries here in that network policy. These are 2 rules. If you, for one or the other reason, forget that dash, it is 1 rule. It's incredibly difficult to figure that problem out. So I really do not like this, because if I would apply this, this would basically override my existing policy. So I prefer basically to create an additional policy here, yeah, and that will allow me to do it. If I do kubectl get network policies right now, you will see that I have already like 5 policies. They're all just opening more and more and more room in the communication space. The only one that prevents it is that one that says apply no rules to everything. It's a strange concept, but as I said, I did not invent this. So, for example, I created one so that I could basically connect from a namespace with a label here, yeah, and from a pod with a label. So if you want to check this, I can actually label my hackns namespace as project equals debug. And then I could basically run a pod here. Yeah. So if you look at the syntax, kubectl run blah blah, the namespace, label it with mode equals debug. That's what you see in the pods selector part. Yeah. And the fact that I labeled the namespace is how I identify the namespace. So if everything works out, I should be able to see that right now I can also, from a different namespace, do all my tips and tricks. I added some additional examples to just make it overly complicated. But the last thing I wanted to show is the idea of cluster-wide policies. Now, do not simply copy-paste this, because it could be painful. This is an example which I like personally, and why I use global policies is to basically prevent something or to stop something in a snitch. Yeah? So if you take a look at this policy, you see that's a Sicilian policy, but you will have a similar policy. If you want, I can give it to you for Calico, which I use as quarantining, which is a bad name for this, but anyhow. That means that if my pod is labeled with quarantine equals true, then it is denied access to world. I kept it to world, but you can put it to any. Yeah, so that means that if in any namespace a pod is labeled with quarantine equals true, it won't be able to reach the internet anymore. Yeah, so let's give it a try. Let me exit this here. And now your question becomes more relevant, because what is applied first? Cilium rules, Calico rules, or Kubernetes native rules? As a general rule of thumb, yeah, the rules that are implemented by Calico or Cilium have a higher or lower priority, whatever, but they're applied first, and then, which I didn't say that you cannot configure it to be different. You can put rules behind Kubernetes native rules, but both are supported on the same cluster. So let's see if I can make this work. So I'm gonna create a pod in a namespace here. It's not really a CNI setting in Calico. You have to specify a rule order. Ah, okay. In Calico, you have to specify a rule order. And in Cilium, honestly, never checked. But I guess there will be. but it's only applicable when you start to use drop rules. Yeah. So let me start this spot here. So it's in the HackNS namespace. So there are no rules applied in the HackNS namespace, only in the prod. So I'm going to use the most famous website I ever created. It dates back from 2003 and it still works. So you see, I can reach the DNS and I can actually curl it and it works. Now, the trick here is, imagine that, and I found it good that you talked about it, StackRox thinks at a given moment, that guy is doing something to botnets, or Fortinet tells you you're connecting to a botnet, or an intrusion detection system says they can connect to the Kubernetes API and take an action. And the only action they actually need to do is, okay, we identify this spot as being malicious. As long as you can connect to the Kubernetes API, yeah, and I'm just gonna label that pod with quarantine is true, yeah, and I wait, yeah, it always takes 1 second. You see, that pod is basically locked out from reaching the internet, and there isn't much that pod can do. If you label it to basically egress and ingress to anything, that pod would be totally isolated. Yeah. So it took me a very long time to basically grasp all this and play around with it. You can do that also, but try to understand the concepts, yeah, and the fact that labels, because it's very powerful. I said the only downtime is it's terribly difficult to troubleshoot. I spent like an hour trying to fetch why I didn't get my HackNS fixed, because kubectl get network policies doesn't show the Cilium policies, and the Cilium policies don't show the network policies. So think about that, but for the rest, it makes sense if you configure it. If you learn, try it with Cilium CNI. It has this free logging version, and I always delete it, but normally you would see that for example, my HackNS namespace should show something if there was traffic. Yeah. Yeah. For the sake of the demo, this is not going to work, but you would actually see what happens in the namespace, and you will see the logging, you will see the denies, and so on and so forth. Yeah. Thanks. If you have any questions, feel free to ask them, but I guess I spent my limit. Any questions? Sorry? If it is the same between different CNIs or not, as long as you stick to the Kubernetes native ones, so the ones I showed in the beginning, except this quarantine one, they should work on every CNI. If they implement it, I not want to pick on Redhat because they're in front of me. But for example, there are some subtle difference between the different types of CNI. But for example, they have like namespace isolation, which is very hard to get with native network policy, so it depends. But let's say if you go to these very specific CNIs, they do the basic stuff and much, 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 much more. You can even see the layer 7 flows in this graph.
Is there a documentation which actually defines the standard behavior for Kubernetes? Or you just say like, since GKE uses this, so let's consider this as standard?
They all use a standard. As I said, as long as you stay with native Kubernetes network policies, then they will behave the same. But if you're going to play with like what I showed you with the quarantining, and you go, yeah, it's first of all not compatible, yeah?
Yeah.
And to basically mimic this into Calico, that's pretty difficult.
Yeah.
But for documentation, I learned it from the official Kubernetes documentation because that's the native API. But if you go to docs.calico.org or you go to Cilium, they have like more content that you can ever read about all the, because just to close down here, for example, you see these IDs here. They have like internal IDs they assign to kubelet or to a specific thing so that you can do it based on a name. I have another presentation how I break all this stuff, but and there it becomes important. Maybe one question to leave you off: who uses network policies? Who uses liveness probes and readiness probes? No bad remark. Do network policies, do liveness probes continue to work in my scenario, or readiness probes? Or startup probes, for that matter? It's an exception. Readiness startup probes, they evade network policies. Even the CNI vendors were tricked, but it's in the official, and it's a way to bypass network policies. But if you want, I can give you a presentation on that once. Liveness probes, startup probes, readiness probes, they're all bypass network policies. Except if you would do very advanced things, but thanks.
My name is Klaus, and I'm going to give you a peek into how our product team at Nokia does CI/CD and release engineering. So doesn't mean that all teams at Nokia do it the same way, but most of them follow the same sort of principles at least, but maybe how you do it is a bit different. So first I'm going to talk a bit about our team, who we are, then a bit shortly about what our product is, so you get some context, and then I'll talk about our CI/CD and release engineering practices, and then our security practices, and then summarize. And hopefully for the security practices, we tick all the boxes from Philip and Pieter, that we are doing the right things. So first, our team. So yeah, we are based in Nokia Belgium. We are here in Nokia Belgium. We have one office here in Antwerp in Belgium, 1,200 employees, and it's mostly R&D for network, hardware and software. Nokia Belgium is usually always hiring. Our team is not at the moment, unfortunately, but you can, if you're interested in working here, you can go check out that URL. Our team is called the Virtual Network Orchestration Team, the VNO team. We're led by a guy named Hans van der Straten. He's over here, my boss, waving in the corner. Hi, Hans. Thanks. And we're a smallish team working sort of in startup mode to build cloud-native products for network orchestration. And our niche is sort of in the intersection between IT and telco infrastructure and between IP networking and Kubernetes. And we're, here is sort of an org chart of Nokia, and we have 4 business groups, and we're under the network infrastructure business groups, under the IP networks business unit, and down here, VNO. So what is our product? So, well, this is not our product, but Nokia makes routers and switches, a lot of them. Here are some of them. Common for our switches is that they run either service router Linux or service router operating system. And yeah, these switches, routers, they're used in all sizes of data centers by our customers. So they're from small things to giant, full rack things. One thing in common is that our router switches, the network devices, they support these public APIs. So one thing is Yang, which is a data modeling language for modeling the configuration of your network device, your switch, and for modeling its operational state. And OpenConfig GNMI is a communications protocol based on gRPC for updating or retrieving the configuration state or the operational state of your switch. So these are two nice features that we use in our product. And our first product is called Edge Network Controller, ENC. And it is the boxes in blue here. So it is basically a collection of network operators, Kubernetes operators, and a CNI plugin. So we've learned about what a CNI plugin is. It's just a glorified binary that follows the specification. And what we do is we have custom resource definitions for defining declaring the state of the configuration on your switch. And we also have, we have CRDs for that, so you can create Kubernetes objects to model your switch's configuration and manage it with Kubernetes. And we also have a CNI plugin that allows you to dynamically reconfigure the switch when a workload is deployed. So I won't go into too much detail on this diagram, but basically imagine you have a Kubernetes cluster, you have several worker nodes, your pod is scheduled on one worker node, but you want this pod connected to a certain VLAN, but you don't want to pre-configure your switch ports to hard code them or pre-configure them for VLANs. So we allow you to we will dynamically update the switch configuration when a pod is created. So yeah, I can talk more about this afterwards if you want to know how it works in detail. But basically, yeah, we have a CNI. It creates an object. So we have a CRD for our CNI that contains the configuration that is then applied to the switch eventually. Oops. Our CI/CD and release engineering practices then. So how do we build and deliver this product? So first, some definitions. So release engineering is sort of a well-defined process for releasing your software with ideally as few manual steps as possible. So it's a streamlined, well-defined process that you practice and get better at, because you will be hopefully doing it a lot, creating a lot of releases of your software. Continuous integration is the practice of, for every change you make to your source code, when you merge that, when you integrate that into your main branch or release branch, you verify the change. You run some tests, you do static analysis on your source code, you do whatever you need to do to verify that that change is okay and won't break your product. Continuous delivery is, you're getting changes into your release branch that you have the ability to deliver those to your customers in a, sustainable as fast as possible with as short lead time as possible. And if you are doing these deliveries, continuous deployment is the ability to automatically deploy those delivered releases to your production environment. So in our case, though, if you read sort of DevOps literature and stuff, all these sort of examples, they are like web scale or small startups. They're running their own software as a service, so they have total control over their production environment, and maybe that's your case. I mean, you're running some kind of software as a service, and you are actually building software, running it in production yourself, and you're managing production and so on. But we don't do that. We're basically we're doing the CI and CD, the CI and the continuous delivery. We're creating releases and delivering that to our customers. So we're sort of doing shrink-wrapped software almost, right? So we upload our deliveries, our releases to some software repository somewhere, and then our customers can download and deploy them themselves at their own sort of cadence, at the rate that they are comfortable with. But we have no control really of the production environment where our software is going to be running. So we actually only do the continuous integration and continuous delivery part. But yeah, we try to make it as easy as possible for our customers to do the continuous deployment part too, if they wish to do so. So our R&D tooling, so how we develop our product, we use GitLab for source control. Our product is, we write it in Go and Python. We use the QBuilder framework to build our operators. That's a very common thing. Yeah, we use make for scripting our builds. We use, of course, Kubernetes. We use Vagrants to create reproducible dev setups and test environments. We use something called Container Lab for running simulators of switches. So it's, I think, a project started by Nokia, where we have simulators for our SR Linux and SROS switches, but also other vendors like Cisco, they have also simulators there. So you can try that out and run simulators to test against, for example. And also, we use a centralized continuous integration platform at Nokia that one of the business groups, basically the software division of Nokia, they run a centralized CI platform that our team leverages, even though we're not in that business group. But it has Jenkins, it has a Kubernetes-based build cluster. They have JFrog Artifactory, which is a competitor to Nexus that was mentioned before, and they have various security scanning services. And if you're more interested in that central CI platform, I gave a talk at Configuration Management Camp Ghent 2 years ago, where I talk a bit about how we migrated that thing from OpenShift to AWS. So you can go check out those slides if you're interested. So our product, what is it? What is our product actually? What are our deliverables? What's in our release? So our product consists of what we call product components. So each product component is a thing that can be released either together with all other product components in the product, or it can be released separately. And a product component, that can be a collection of container images, Helm charts, documentation, examples, other stuff. And we basically wrap all that up into a tar.gz file, a tarball. And yeah, the product component source code, it's in a Git repo. We don't have a mono repo. We have one Git repo per product component. Of course, we have automated tests, test suites, and each product component has a CI pipeline for building it, verifying it, running all the tests, etc. And usually for major releases, we will ship all product components together, one big bundle that we give to our customers. But we also need to have the capability of releasing them separately. For example, say there's a vulnerability in a dependency we have, a third-party library in our CNI plugin. We don't want to have to ship a new version of the operator just because we have to fix the CNI plugin. So we need to have the ability to do fine-grained releases of our product components. And yeah, here's a diagram or showing our CI/CD flow. But basically, the normal R&D cycle is, yes, a developer makes a change, it gets code reviewed, it gets merged into the main branch, the master branch, the release branch, and then a CI pipeline kicks off and verifies the change. So runs like static analysis on the code, linting, test suites, etc. And then at the end of that, we produce a release candidate that we publish to Artifactory, to the software repository. So this tarball I mentioned. Then after that, so every time we do a change, we produce a new release candidate that can, in theory, be released and delivered to the customer if we choose to do so. So it's just a business decision from that point on. Do we want to attempt to take this release through all the quality gates? Because when we release, we have to run some additional tests that are sort of expensive to run, so we can't run them for every change a developer makes. We only run them they could be a soak test that has to run for days, or performance tests, stress tests, or extra security pen tests. So yeah, we when we get close to release time, we decide, okay, we're going to try to get this release candidate through all the quality gates. And then if we do that and it passes, okay, then we can choose to say, okay, we are going to release this. And then it's also just a business decision again to promote this release candidate to released. And we're not rebuilding anything, we're just like moving this artifact, the tarball that we already tested, to a different location so that our customers can access it and download it. Of course, there's a bunch of other sort of release bureaucracy you have to go through, but that's sort of the important part. We're not rebuilding anything, the bits are exactly the same. These are our CI principles. So I mentioned some of them already, but the main branch must always be in a deployable, releasable state. So we never commit anything or merge anything that we know is going to break functionality. If we do break something accidentally, the priority is fix that. So if the build is red, so the Jenkins build is red, we have to fix that first before we continue work. A change is not considered done unless it has automated tests. Any change we make has to go through a code review or a merge request, so similar to pull requests on GitHub, but this is GitLab, so it's called merge requests. So that's a peer on the team has to review, sort of part for knowledge transfer and also to try to help detect problems. And yeah, the merge request is also a CI pipeline is run to verify the merge request. Then ideally, merge request build should take less than 5 minutes, and once you get something merged to the main branch, it should take less than 15 minutes, but as your product grows, this gets harder and harder to do. You add more tests, it takes longer to compile, etc. So it's not, we aim for that, but we're honestly not meeting those two target times, unfortunately. Then one important thing is that developers and the CI pipelines have to use the exact same tooling and the exact same versions. And this also, so we're not, if we're using, everyone should be using the same version of Go, the exact same version of Go, the exact same dependencies, the exact same kubectl version. Everything, everywhere is, we pin the versions. And it's, yeah, go ahead. Yeah, so I mentioned we use Vagrant. So all our dev setups are based on Vagrant. So we have a Vagrant box, so a Vagrant file defining, like these are all the tools. Yeah, so we have to distribute that, and you occasionally have to refresh your Vagrant VM that you're running. And the CI pipeline, it does not use that Vagrant VM, honestly, but it uses, we build in a Docker container. But the same versions are used in that container. And this, I mean, this is a bit sort of tedious, can get a bit tedious to manage. It's not trivial because once you have multiple releases, like the current release on our main branch is Go 119, the previous release was 118. So depending on if you're fixing a bug or running a CI pipeline for what release, you will have to use different versions of the tooling. And lastly, as I mentioned, we never rebuild anything when it's release time. We just take the thing we already built and have taken through all the quality gates, or through all the verification, and that is the thing we promote. So it's just a matter of moving that to a different location. So onto our security practices. So each product component must have a software bill of materials. I think we talked about this already in today in a different talk, the concept of an SBOM. And yeah, there's tooling that generates this, so it's not that hard to do nowadays. But basically, that's a list of all your third-party dependencies and the versions. So what we try to do is we try to minimize the number of third-party dependencies we have. I mean, it's great open source projects with functionality, so you don't have to write it ourselves, and we use a lot of third-party packages, of course. But we think carefully before adding a new package to our dependencies, because this increases the sort of attack surface of your product. Because the more dependencies or third-party dependencies you have, the more packages that are going to be scanned for vulnerabilities, and the more often you will probably have to release security patches because of a third-party component with a vulnerability. We also always pin all those versions, and we use the exact same versions across all our product components, so that we don't use version 1.2.3 of one library, and then on another product component we use that library but 1.2.4. We always use the same versions everywhere, and we pin to those versions. We also try to use, we also use minimalistic base container images. So our product, and ideally we use something like Google's distroless image, where the only thing in the container image is our layer with our binary, our Go binary. So there's no shell, there's no cat, there's no bash, there's nothing that can have a security vulnerability in that container image. And when we do inherit from, we have to inherit from the distroless image, we don't pin to a label or anything of that image, we pin to the SHA-256 signature. So we're always like pinning to signatures because labels, container image labels are mutable. I mean, there are immutable ones too, but usually, they are not. And definitely never use the latest. Be explicit. We update third-party libraries frequently, at least once per release cycle we do this, usually more often because during our release cycle when we're developing the next version, there are going to be vulnerabilities found in the third-party dependencies we have, so we have to continuously sort of keep those updated as soon as something is flagged. I didn't mention that, but in our CI pipeline, for each build we do of our, for each merge request build and main branch build, we do scan for vulnerabilities. So you cannot even merge your change if at the point merge time there is a vulnerability. But of course, vulnerabilities can be found later on because the security researchers are continuously discovering vulnerabilities in open source projects. So even if you released your software today and it was fine, tomorrow you can have a critical vulnerability because someone found something and there's a new CVE. We use the principle of least privilege everywhere in our product and our sort of local infrastructure too. So that was talked about a bit, and so we don't run as root, no privileged containers. We minimize the use of cluster roles. Of course, if you're building an operator, you need to have a cluster role because you're watching for your objects of your CRD everywhere in the cluster. But things like this, resource requests as well, to avoid sort of denial of service takeovers of a host. We use encrypted communication everywhere internally in our application, and we auto-generate and auto-refresh TLS certificates so that, they're not going to expire and break something, and it's good to not have very long or sort of long-running or certificates that are allowed to last for years. That all got sort of once we got Let's Encrypt, this great service where you can get free certificates, and it's completely automated certificate generation and signing. That's sort of set the standard that, 30-day certificates or whatever it is, that is the new normal. And we use Cert Manager for this, a nice little sort of operator for generating and signing certificates. For each release we make, each product component release, this tarball, it has a cryptographic signature, so a SHA-256 checksum that we ship, so you can verify the integrity of it. What we do not do yet, but we should do, is to cryptographically sign the artifact as well, so that you can verify its origin, so that it came from Nokia, actually, because someone could take our tarball, manipulate it, generate a new SHA-256 signature for it, and give it to you, and sure, it will be verified as integrity check passes, but it's not from us anymore. So that we need to do. And we'd also like to implement, there's a new interesting framework, security framework called SALSA, Supply Chain Levels for Software Artifacts, which is basically a framework that you should with different, let's say, grades of compliance, that I think is a very nice sort of framework to try to grade yourself and know what to strive for related to security. We also have our CI platform, so that was our product, some of our practices in our product. In our CI platform, some features in this centralized platform that we use. All builds run there are isolated in a container. Nothing can be cached between the builds, so there's no cached build workspace between builds, so that's good and bad. I mean, it means all your builds will take a bit longer because you cannot cache compiled results from a previous run of your build. So when each Jenkins pipeline starts a new run, it is from an empty workspace with nothing in it. This works for us, but it's depending on your size of your product, it might not work. The build environment has no access to the public internet, so if you want to download something, you have to go via local caching proxy where the artifacts are stored. This is nice because that caching proxy, in our case it's Artifactory, it has the ability of, it continuously scans all packages, all artifacts in it for known vulnerabilities, and if a vulnerability is found, a CVE that is above a certain threshold, it will block that so no one can use it by default. So you can already block things at the artifact repository. And also, it's also scanning all our releases that we've published there as well continuously. So as soon as a release we have published there, there's a vulnerability found, we will find out that way too. We will get a notification. This Artifactory, the software repository, it also generates a bill of materials automatically. And yeah, we continuously scan. It continuously scans everything we have for vulnerabilities and also for malware. So that's probably less likely, but it could happen that, yeah, there's some malware that gets injected somehow into your software. Ideally, that should never happen because the CI environment should be secured and locked down. But it can happen, and then hopefully this continuous malware scanning will detect that. Because also, yeah, malware databases are continuously upgraded or updated. So even if at the time you release your software, there's no malware in it, yeah, a month later, there could be some malware detected. Okay, so yeah, that was, I guess I spoke a bit fast, but okay. To summarize then, our team, we prioritize keeping the product in a releasable state. We optimize for delivering releases with as few manual steps as possible. So we really try to optimize that the release engineering part, and it's as little manual steps as possible. That takes time, of course. It's not trivial. I mean, we've worked on this over several iterations of our releases. We did not get it all right from the beginning, but yeah, it's just something you have to work on and yeah, practice. And the more painful it is, the more you should practice it. But yeah, in our case, it's also, if you're doing shrink-wrapped software like us, and maybe you have a release cadence of every quarter, you don't get that many times per year to practice it. So you have to really force yourself to do it maybe more often than you really need to. Yeah, humans, so us developers and the CI pipelines, we use the same tools and versions everywhere. They're pinned. We tightly monitor and control our software dependencies, so the third-party packages we depend on. And yeah, the CI infrastructure is locked down because that is basically a remote code execution environment. And yeah, if you're pulling stuff from the internet and running it in a container in your CI environment, then things are not, yeah, locked down. Yeah, bad things can happen, of course, like this SolarWinds supply chain attack. That was some variant of that happened. Yeah, so, but ultimately, we're doing all of this so that we can, with sort of confidence and peace of mind, ship our product to our customers with the end goal of, yeah, automating and orchestrating their network. So all of this is, yeah, to improve the lives of our customers. Okay, that was all I had. Any questions? One question.
Thanks. No, just out of curiosity, you mentioned you're looking into signing your artifacts.
Yeah.
Do you have already done some research there, or?
Yeah, well, we have in Nokia an internal tool for this. Because, I mean, our artifacts, they're not open source. They're not going in some public registry or something like that. So we cannot use SigStore or cosign on those fancy things. So it has to be a proprietary thing. But it's basically it's the same. We have a service. We sign this list of artifacts with these checksums, and we get back a signature. Yeah.
Okay, cool.
Yeah. So, but we would like to use stuff like SigStore, but yeah, we can't. Yeah.
Yeah, that was my question.
Yeah. Okay, any other questions? Yeah, Nokia, we run our own private GitLab. We do not use a hosted GitLab. Yeah. So there's well, actually, there are several instances, but yeah, there's like a dedicated IT team running that. So it's not our team running it, it's a sort of a central service provided by IT. Yeah.
Any reason why you didn't why you chose Jenkins over GitLab CI? Yeah.
So this CI platform we're using, it is based on Jenkins. So, and yeah, actually before we switched to that, we were also using Jenkins in our lab. But yeah, I mean, Jenkins, I'm sure it's showing its age a bit, but it does the job quite well. But yeah, maybe in the future at some point we will try out GitLab, but yeah, we don't have any concrete plans for that, for switching to GitLab CI. But yeah, that would probably be the natural alternative since we're running GitLab. Yeah. Yes.
You're also distributing your artifacts, your containers and Helm charts to your customers.
Yep.
Is that also through JFrog or?
Well, I don't know if I can say that. I bet Nokia has like a legacy proprietary way of distributing the software, but there is also sort of a continuous delivery initiative to do that, and I think that is probably based on JFrog Artifactory. Yeah. Any other questions? No? Okay. Thanks then. You can come ask me questions afterwards. We can stay around for, I don't know, a while longer if you want to just finish off if there's anything left to eat or drink. Yeah, so there's no rush. Okay, thanks everyone. Yeah, that was it then, I guess, for today. Cedric, do you want to say something? Okay, yeah, well, thanks everyone for coming and joining us here at Nokia today. It was great to have you, and hope to see you again at the next meetup, wherever that will be. Do we have any hints yet? No idea? Or when it will be? No, not yet. Okay, yeah. Okay, great. Okay, thank you everyone.